You went to bed thinking about someone you decided you were done thinking about. Science has a name for what's happening in your brain right now. The mind doesn't archive emotional memories the way you'd file a document. Closed. Labeled. Set aside. It processes them. Repeatedly. During sleep. Especially during the hours when REM is deepest. Why can't we stop dreaming about someone we've already decided to move on from? That question is where tonight begins. Here's the part that changes everything. The replaying isn't a failure of willpower. The research shows it may be the mechanism of healing itself. The brain that keeps returning to someone you've lost is not broken. Welcome to Sleepy Mind Science. It is working. Close your eyes and breathe slowly. You're somewhere the unfinished things don't have to be finished tonight. Let your mind soften around what it carries. And now we begin. When you wake at 3 a.m. with a vivid image of someone you used to love, you are experiencing one of the most studied phenomena in sleep neuroscience. The brain's emotional memory consolidation system is most active during REM sleep, the stage that dominates the second half of the night, between approximately 2 a.m. and 6 a.m. During these cycles, the prefrontal cortex, the region responsible for rational evaluation and emotional regulation, becomes selectively less active. The amygdala, which processes emotional significance, becomes more active. This combination creates a state where emotionally charged memories can surface without the usual filtering. The question researchers have been asking for decades is not why this happens, but what it is for. The brain does not consolidate all memories equally. Emotionally significant memories receive preferential processing. They are tagged by the amygdala with something neuroscientists call emotional salience. This tagging signals to the hippocampus, the brain's primary memory consolidation center, that this experience requires additional processing. Studies using fMRI imaging have shown that the same brain networks active during an emotionally significant waking experience reactivate during REM sleep. The technical term for this is offline memory reactivation. The word offline is precise. The brain is running emotional memory processes during sleep, not as passive storage, but as active computation. Unresolved emotional experiences receive the most reactivation and the most replaying. Emotional closure. The sense that a relationship, a loss, or an unresolved experience has been fully processed, is not a moment. It is a process. Sleep researchers have found that emotional closure involves a gradual reduction in the intensity of an emotional memory over successive nights. Each REM cycle does a small amount of the work. The memory itself doesn't disappear. What changes is what neuroscientists call the affective charge, the emotional weight attached to the memory. A newly ended relationship carries maximum affective charge. Over weeks and months of REM processing, that charge typically diminishes. What begins as a memory that causes physiological arousal, elevated heart rate, cortisol release, muscle tension, becomes, over time, a memory that can be recalled without the same physical response. The neuroscientist Matthew Walker at UC Berkeley has described REM sleep as a kind of overnight therapy, a period during which the brain processes painful experiences while separating the emotional tone from the narrative content. During REM, the brain's norepinephrine system, the same neurochemical involved in the fight-or-flight stress response, reaches its lowest point. REM is the only sleep stage in which norepinephrine is essentially switched off. Walker's research suggests this is not incidental. The absence of norepinephrine during REM creates a unique neurochemical window in which the brain can revisit emotionally charged memories without the physiological stress response that accompanied the original experience. It is, quite literally, the safest time for the brain to process what hurt. Dreams involving a former partner are not random. They are assembled from specific memory components that have been flagged for processing. The brain's memory consolidation system during REM sleep does not simply replay experiences in sequence. It recombines them, drawing connections between the current emotionally unresolved material and older memories that share emotional themes. This is why a dream about an ex-partner might contain unexpected elements, other people, different settings, events that didn't happen. The brain is not replaying a recording. It is running a simulation, testing different framings of the unresolved emotional content to find a pattern that can be integrated. The strangeness of dreams is not noise. It is the search process. The hippocampus and amygdala work together during REM sleep consolidation in a coordinated cycle. The amygdala evaluates emotional significance and retags memories by intensity. The hippocampus then coordinates the reactivation and partial re-encoding of those memories in the neocortex for long-term storage. Research from the University of California has shown that this process is essential for emotional learning. The ability to modify our emotional response to a stimulus over time. When a relationship ends, the brain treats the associated memories as an open emotional learning problem. The amygdala continues to flag them as requiring resolution. REM sleep is where the resolution work happens, one night at a time. There is a particular type of dream that appears repeatedly in the literature on emotional processing, the revisitation dream. These are dreams in which a person returns to a place, a relationship, or a period in their past that carries unresolved emotional significance. Sleep researchers have noted that revisitation dreams increase in frequency during periods of emotional transition, after loss, separation, relocation, or major life change. The dreaming brain appears to use familiar emotional landscapes as a processing scaffold, returning to a known emotional environment to do new integration work within a familiar frame. The person in the dream is not always who they were. The place is familiar. What happens there is new. Cortisol, the stress hormone, follows a predictable circadian rhythm. It is at its lowest in the early night and rises sharply in the hours before waking. Peaking around 8 a.m., this cortisol rise in the final third of the night serves a biological function. It prepares the body for the demands of waking. But it also means that the final REM cycles of the night, the longest and emotionally richest, occur as cortisol begins to climb. Research has suggested that this overlap influences the emotional tone of late-night dreams. Higher cortisol correlates with more emotionally intense dream content. The dreams that wake you at 3 a.m. or 5 a.m., the ones that feel vivid and unsettling, occur at the intersection of maximum REM activity and this rising cortisol curve. Not all people process grief and loss through dreams at the same rate. Research on REM sleep and emotional regulation has found that individuals with higher baseline emotional processing capacity, those who naturally engage in more reflective thinking about emotional events during waking life, tend to process emotionally significant memories more efficiently during sleep. Conversely, individuals who avoid emotional reflection during waking hours, a pattern sometimes called experiential avoidance, tend to show more frequent and more intense emotional dreams. as the REM system compensates for reduced daytime processing. The brain's overnight system and the daytime emotional processing system are in constant dialogue. What isn't processed in daylight comes back in the dark. The research accumulated over the past 2 decades converges on a finding that is counterintuitive but consistent. The presence of emotionally significant dreams about someone is not evidence that the processing has failed. It is evidence that it is ongoing. The dreaming brain is not stuck. It is iterating. Each night's REM processing represents a pass through the unresolved material, not to resolve it entirely, but to reduce its charge by a small, measurable amount. Why can't we stop dreaming about someone we've already decided to move on from? Because the decision to move on is a conscious act, and the emotional integration required to make that decision feel complete runs on a different timeline, one that belongs, at least in part, to sleep. The concept of emotional memory reconsolidation is one of the most significant developments in sleep neuroscience in the past decade. When a memory is retrieved, either in waking life or during dreaming, it enters an unstable state. During this unstable window, the memory is susceptible to modification before it is restored. Sleep researchers have found that REM sleep facilitates a specific form of reconsolidation. The emotional tone of a memory can be updated even when the factual content remains intact. This means the brain can, through repeated REM processing, preserve the episodic content of a memory. What happened? When? Who was there? While gradually modifying the emotional weight attached to it. The memory of a person doesn't disappear. The pain attached to it can change. The default mode network, a set of interconnected brain regions active during rest, self-reflection, and mind-wandering, plays a central role in processing relationship-related emotional memories. This network, which includes the medial prefrontal cortex, the posterior cingulate cortex, and the angular gyrus, is preferentially active during both REM sleep and during the wakeful reminiscing that follows loss. Research from neuroimaging studies has shown that individuals with stronger default mode network activation during sleep show better emotional recovery outcomes over time. The brain regions that replay memories of someone in your waking thoughts are the same regions doing the emotional integration work in dreams. The replay isn't separate from healing. It may be the mechanism of healing. Sleep deprivation has a specific and well-documented effect on emotional memory processing. When REM sleep is curtailed by stress, by alcohol, by early waking, the emotional charge on unresolved memories is not reduced. It accumulates. Studies have shown that sleep-deprived individuals show hyperactive amygdala responses to emotionally negative stimuli. Their emotional reactions are larger, more difficult to regulate, and longer lasting. The same memories that a full night of REM sleep would have reduced in intensity instead become more intrusive when sleep is cut short. This creates a cycle. Emotional distress reduces sleep quality. Reduced sleep quality increases emotional reactivity. Increased emotional reactivity intensifies the next night's dreams. The sleepless nights after a breakup are not incidental to the emotional pain. They are part of it. Research on grief has consistently found that the dreams of bereaved individuals serve a specific psychological function. Studies following individuals through the grieving process have documented what researchers call integrative dreams. Dreams in which the deceased or absent person appears, often behaving in ways that provide the dreamer with a sense of closure. resolution, or continuation. These dreams are not random artifacts of emotional distress. Bereaved individuals who report more vivid and more frequent dreams of the deceased show, on average, better long-term grief outcomes than those who do not. The dreaming system functions as an emotional processing engine that runs more intensively when the unresolved emotional material is more significant. Loss of any kind activates this system. The emotional content of dreams is not static across a period of grief or separation. Sleep researchers who have tracked dream content longitudinally, following the same individuals over weeks and months after a loss, have found a characteristic pattern. In the early weeks, dreams involving the lost person tend to be emotionally intense and often distressing recreations of arguments, scenes of departure, or ambiguous encounters that leave the dreamer unsettled. Over time, typically measured in months rather than weeks for significant losses, the emotional tone of dreams shifts. The person remains present in dreams, but the content becomes more neutral, more ordinary, and eventually more positive. The arc of dream content mirrors the arc of emotional healing. The question of why the brain replays certain relationships and not others is, in part, a question about attachment. Attachment theory, developed by John Bowlby and expanded by decades of subsequent research, proposes that the human brain forms internal working models of significant relationships, cognitive and emotional maps of how connection functions, what to expect, and what is safe. When a relationship ends, the internal working model built around that person doesn't immediately update. It continues to generate predictions, expectations of presence, anticipations of familiar patterns that now go unfulfilled. This mismatch between the brain's existing model and the new reality is one of the primary drivers of both intrusive waking thoughts and recurring dreams. The brain is not pining. It is revising a model. Research on what is called relationship dissolution, the psychological process of cognitively and emotionally separating from a former partner, has found that this process involves specific neurological changes over time. Studies using fMRI imaging have compared brain activity in recently separated individuals versus those further along in recovery. Early-stage separation shows heightened activity in the anterior cingulate cortex, the region involved in processing social rejection and physical pain, and in the reward system's dopaminergic pathways. The brain, at this stage, is not only grieving a loss, but also experiencing what functions neurologically as a form of reward withdrawal. The romantic attachment system and the brain's reward system are deeply intertwined. The dopaminergic reward system's involvement in romantic attachment is one of the more striking findings from neuroimaging research on love and loss. Studies by Helen Fisher and colleagues at Rutgers University found that when individuals viewed photographs of their romantic partners, activity increased significantly in the ventral tegmental area and the caudate nucleus, core regions of the brain's reward circuitry. The same regions active in states of intense motivation and goal pursuit. When that relationship ends, the neural pattern doesn't simply switch off. The reward system calibrated to the presence of that person continues to generate an internal state of wanting. A wanting that now has no available resolution. The dreaming brain revisits this system during REM sleep, processing its recalibration night by night. There is a body of research on a phenomenon called emotional residue, the persistence of an emotional state beyond the event that originally triggered it. Studies in affective science have found that emotional states, particularly those associated with significant relationships, have a half-life that extends well beyond the original experience. This residue is not a sign of pathology. It is a feature of how the brain encodes biologically significant events, those involving attachment, loss, and social belonging, which, from an evolutionary standpoint, warranted sustained attention and learning. The brain treats the end of a significant relationship as a high-priority learning event. The emotional residue is the substrate of that learning. It persists because the learning isn't yet complete. A significant line of research has examined the relationship between rumination and REM sleep activity. Rumination, the tendency to repeatedly and passively focus on negative feelings and their causes, is known to interfere with sleep onset and sleep quality. But the relationship between rumination and REM sleep is more nuanced than simple disruption. Studies have found that individuals who engage in rumination during waking hours have longer REM periods and more frequent emotional dream content. Researchers have proposed that the REM system may be partially compensating for incomplete daytime processing. The emotional material that ruminative thought circles without resolving is being handed off to the REM system for a different kind of processing. The rumination is not working. The dreaming may be. The role of the prefrontal cortex in emotional memory processing during sleep illuminates something important about the difference between waking and dreaming. During waking reflection on a painful memory, the prefrontal cortex is active. It provides context, judgment, narrative coherence, and the ability to suppress or redirect emotional responses. During REM sleep, prefrontal activity is substantially reduced. Researchers have proposed that this reduction is functionally significant. It allows the emotional content of a memory to be processed without the constant modulation of rational interpretation. The dreaming brain encounters the emotional experience more directly, without the story the waking mind uses to contain it. This directness may be precisely what makes REM processing more efficient at reducing emotional charge than conscious reflection alone. Research on REM sleep and emotion regulation has found specific effects on emotional memory that distinguish sleep from other forms of recovery. A study from the Walker Laboratory compared the emotional memory processing of individuals who slept between two viewings of emotionally arousing images versus those who stayed awake. Those who slept showed significantly reduced emotional reactivity to the images on second viewing. Reduced fMRI amygdala response. Reduced skin conductance. Reduced self-reported distress. Those who remained awake showed no reduction. Napping with REM sleep produced a partial effect. The reduction in emotional charge was not a function of time passing. It was a function of REM sleep occurring. The neurochemical environment of REM sleep, specifically the absence of norepinephrine combined with elevated acetylcholine, creates a state that neuroscientists describe as neurochemically unique. In no other brain state are these two conditions simultaneously present. Acetylcholine, which promotes neural connectivity and associative thinking, is at its highest during REM. Norepinephrine, which promotes vigilance and stress response, is at its lowest. This combination produces a brain state that is highly generative, capable of making novel connections between emotional memories, and simultaneously calm. The brain is doing its most creative associative work in its least stressed state. Emotional healing, the research suggests, requires both of these conditions at once. The experience of dreaming about someone and then waking with a renewed sense of loss. The dream crash that many people describe after separation is a well-documented phenomenon. Sleep researchers have noted that this experience is most common in the early stages of processing a loss, when the brain's updating of the internal model is still incomplete. Upon waking, the prefrontal cortex re-engages and recognizes the discrepancy between the dreaming state and waking reality. The emotional pain of this recognition reflects the gap between where the brain's emotional model is and where it needs to eventually be. The crash is not a setback. It is, neurologically, evidence that the model is still being revised. 25 facts in. And what is emerging is a pattern that changes the question we started with. Why can't we stop dreaming about someone we've already decided to move on from? Because the decision is made in one system and the processing happens in another. The prefrontal cortex can decide. The amygdala, the hippocampus, the default mode network. These systems don't receive a memo. They process on their own timeline, according to the emotional significance of the material, running their passes through REM sleep, one night at a time. The decision to be done is not the same as being done. What the next arc follows is the question of what changes that. And what, specifically, sleep is doing each night to close the distance between the two. Right now, somewhere in the networks that just processed these 25 facts, there are memories tagged for tonight. Not tonight's facts. Older ones. The kind your waking mind doesn't always access directly, but that the system running beneath it has been cataloging for weeks, or months, or longer. You don't need to find them. They are already in the queue. The question that just opened, about what changes the distance between deciding and being done, isn't abstract. It may be something your REM system has been working on every night without telling you. Notice your breath. The processing has already begun. Now we continue. The timeline of emotional recovery following the end of a significant relationship has been studied across multiple longitudinal programs, and the findings consistently challenge assumptions about how long healing takes. The commonly cited time frame, half the length of the relationship, has no empirical support. What the research does support is considerable individual variation, shaped by the nature of the attachment formed, the circumstances of the separation, the presence of social support, and, crucially, sleep quality during the recovery period. Individuals who maintain consistent, high-quality sleep in the months following a significant loss show measurably faster reductions in emotional reactivity to stimuli related to the lost relationship than those whose sleep is disrupted. The brain structure most consistently implicated in the persistence of attachment-related memories is the amygdala, a small, almond-shaped structure in the medial temporal lobe. The amygdala doesn't store memories itself. The hippocampus does, but it tags them. It determines which experiences are emotionally significant enough to receive priority consolidation. Research has shown that the amygdala's response to stimuli associated with a former partner remains elevated for a substantial period following separation, even in individuals who report having moved on. This elevated response is measurable through fMRI imaging and correlates with the intrusive quality of associated memories and dreams. The amygdala's assessment of significance doesn't update when a relationship ends. It updates through repeated processing. Sleep spindles. brief bursts of neural activity during non-REM sleep, have emerged as an unexpected player in emotional memory processing. While REM sleep handles the emotional charge reduction work, sleep spindles appear to serve a complementary function, facilitating the transfer of emotionally significant memories from the hippocampus, a temporary storage system, to the neocortex, where long-term memories are ultimately held. Research has found that individuals with more sleep spindles, occurring in coordination with hippocampal slow oscillations, show better emotional memory integration. The architecture of a full night's sleep, the cycling through non-REM and REM stages, is the processing system. Each stage plays a different role. The phenomenon of intrusive thoughts, unwanted, involuntary memories of a former partner that arise during waking life, is closely related to, but distinct from, dream processing. Research has identified the hippocampus as a key generator. It produces spontaneous memory reactivations of highly emotional events, particularly during states of low cognitive demand, resting, commuting, lying in bed before sleep. These waking intrusions and the dream state processing during REM appear to form a coupled system. The same memories flagged by intrusive waking thoughts are prioritized for REM reactivation during the subsequent night of sleep. The brain's offline processing system doesn't wait for sleep to begin. It starts identifying tonight's processing priorities during the day. The role of social support in accelerating emotional memory processing has been studied from a neuroscientific perspective. Researchers found that disclosing emotional experiences to another person, putting them into words, receiving a responsive listener, activates prefrontal and anterior cingulate regions involved in emotional regulation and narrative integration. This verbal processing during waking life appears to reduce the amygdala's salience tagging of the associated memories, which in turn reduces the burden placed on REM sleep processing. Talking about it is not separate from sleeping through it. They work together. Daytime verbal processing and nighttime REM reactivation are complementary channels of the same healing system. Research on counterfactual thinking, the tendency to imagine alternative scenarios, such as, what if I had said that differently, has found that this form of mental activity is particularly persistent following relationship loss. Counterfactual thoughts are generated by prefrontal and default mode network regions involved in planning and future simulation. From the brain's perspective, counterfactual thinking attempts to extract a learning signal from an unresolved event, to identify what went differently than expected and update behavioral models accordingly. The problem is that it rarely finds a stable conclusion. The simulation space is too large. The dreaming brain addresses counterfactual emotional questions differently, not through logical simulation, but through narrative recombination. The neuroscience of forgetting is often misunderstood. The brain does not erase memories. It adjusts their accessibility and their emotional charge. What we experience as forgetting someone is rarely a true deletion. It is more accurately a gradual reduction in retrieval frequency, a decrease in involuntary reactivation, and a reduction in effective charge upon retrieval. Studies using neuroimaging have shown that memories of former romantic partners don't disappear from the brain's storage systems. Their associated neural representations remain detectable for years. What changes is how those representations are tagged, how much priority the retrieval system assigns them. The goal of healing is not to erase. It is to change what the memory carries when it surfaces. Animal research. particularly studies in mice and rats, has provided mechanistic insight into how REM sleep affects emotional memory. Using optogenetics, scientists have been able to selectively disrupt REM sleep's emotional processing function without disrupting other sleep aspects. In these animal studies, subjects deprived of REM processing for emotional memories showed sustained fear responses to previously conditioned stimuli, even after contexts that normally produce extinction. Subjects with intact REM sleep showed normal extinction curves. They gradually stopped responding fearfully to stimuli that no longer predicted threat. These animal findings support the hypothesis that REM sleep is not optional for emotional recovery. Translational research suggests similar mechanisms may operate in humans. The question of whether grief can be worked through faster with deliberate interventions. Therapy, journaling, intentional reflection has been studied extensively. The consistent finding is that interventions increasing narrative coherence around a loss, helping a person develop a coherent story about what happened and what it means, are associated with better outcomes and faster reductions in emotional distress. This finding has a sleep neuroscience correlate the default mode network, involved in narrative self-construction, is the same network that activates during REM sleep processing. The brain's approach to building a coherent narrative about a loss in waking life may use overlapping neural infrastructure with its approach to processing that loss in dreams. Story building accelerates what the dreaming mind is working to do on its own. Research has extended the emotional processing framework to ambiguous loss, situations in which a relationship ends without clear closure, ambiguous losses, those that ended without a definitive conversation, that linger in the space of possibility, that lack the social rituals of acknowledged endings, are consistently associated with more prolonged and intense emotional memory processing, both in waking and in sleep. The amygdala has difficulty reducing salience on memories associated with unresolved outcomes. The brain's model revision process requires something to update toward. An ambiguous ending provides no stable new information. The REM system keeps running passes, looking for a pattern that doesn't yet exist. The timing of grief dreams across the night provides information about the type of processing occurring. Earlier night dreams, during the first and second sleep cycles, are associated with lighter REM sleep and tend to feature more factual, narrative-based content. Later night dreams, occurring in the third through fifth cycles, which are longer and more emotionally intense, are associated with more emotionally charged, more abstractly recombined content. The 3 a.m. dream that wakes you with a specific vivid image is almost certainly occurring during a long REM period. The brain's processing of the most emotionally significant material is concentrated in these late-night, deeply immersive REM windows, which is why late-night waking during emotional periods is so common. The body's physiological response during REM sleep is, in certain ways, paradoxical. The brain is highly active, more active in some regions than during alert waking. But the body is largely paralyzed. Skeletal muscles are actively inhibited by the brainstem's atonia mechanism, which prevents people from physically acting out their dreams. Heart rate and respiration become irregular, variable in a way that mirrors emotional arousal. Research has found that during emotionally intense REM dreams, heart rate variability increases significantly. The body is responding to what the dreaming brain is processing as real. The physiological engagement in dream state emotional processing suggests that the processing is not merely cognitive, it involves the body, just as the original emotional experience did. Alcohol consumption, often used as a sleep aid during emotional distress, has a specific and well-documented negative effect on REM sleep and emotional processing. Alcohol suppresses REM sleep in the first half of the night. As the alcohol metabolizes, a REM rebound occurs in the second half, producing more intense and more fragmented REM sleep. The net result is disrupted emotional memory processing, reduced total REM time, and less coordinated amygdala-hippocampal activity. Research has found that individuals who use alcohol to manage grief-related sleep disturbance consistently show slower emotional recovery trajectories. The short-term relief trades against the processing that would have occurred in those suppressed REM cycles. Research on emotional granularity, the ability to precisely identify and differentiate between emotional states, has found that individuals with higher emotional granularity process loss more efficiently. People who can distinguish between angry, betrayed, abandoned, and disappointed, rather than experiencing all of these as undifferentiated bad feelings, show faster amygdala normalization following loss. Neuroscientist Lisa Feldman Barrett at Northeastern University has proposed that emotional granularity may reduce the amygdala's processing load by providing the prefrontal cortex with more precise information, allowing more targeted regulation rather than broad suppression. The ability to name what you're feeling with precision may reduce how much your REM system has to work to figure it out during sleep. The evidence gathered across the first 40 facts suggests a picture that differs from the cultural narrative surrounding heartbreak. The cultural narrative frames the replaying of an ex-partner in dreams and thoughts as a failure of will, of moving on, of self-possession. The neuroscientific picture frames it as a process, one with a known mechanism, a measurable trajectory, and a biological purpose. The brain that keeps returning to someone isn't holding on. It is doing something specific and necessary, reducing emotional charge, revising internal models, building a narrative that can integrate the loss. The replaying is not the problem, disrupting the conditions under which it happens. Through sleep deprivation, alcohol, avoidance, is what prolongs the process. You've been listening for a while now, and somewhere in these facts, something may have shifted slightly. Take a slow breath. Notice your jaw, your shoulders. We're moving through the science of what heals. Together, in the quiet. One fact at a time. Let's continue. Slowly. The research on cognitive reappraisal, a form of emotion regulation in which a person consciously reframes the meaning of an emotional event, has found that this strategy reduces amygdala activation and improves emotional outcomes. But its interaction with sleep reveals something important: reappraisal during waking life and REM processing during sleep work on the same material through different mechanisms. Waking reappraisal changes the narrative frame around a memory. REM sleep changes the emotional charge attached to it. The most effective recovery trajectories appear to involve both conscious reframing during the day and uninterrupted REM sleep during the night. The mind that actively works to find meaning in a loss, not to minimize it, but to integrate it, appears to give the sleeping brain better material to work with. The phenomenon of post-traumatic growth, the psychological development that sometimes follows significant loss or difficulty, has a neurological substrate that involves sleep. Research has found that individuals who show post-traumatic growth a deepened sense of meaning, strengthened relationships, or new psychological capacities following adversity, show distinct REM sleep patterns during the recovery period. Specifically, they show increased activity in the default mode network during REM sleep, and their dreams during this period tend to involve more complex narrative integration rather than simple replay. The brain's overnight processing, when given the right conditions, appears capable not just of returning to baseline, but of building something new from what was broken. The timing of dreaming about an ex-partner often follows a predictable relationship with waking events. Research on day residue in dreams, the incorporation of recent waking experiences into dream content, has found that emotionally significant waking events increase the probability of related dream content that night. This means that a waking encounter with a reminder, hearing a song, passing a familiar location, receiving a message, increases the likelihood that the associated emotional memory will be flagged for that night's REM processing. The heightened vividness of dreams following these triggering events is not a sign that the processing has been set back. It is a sign that the system has been given a stronger signal to work with. Research on the neuroscience of forgiveness, specifically, the neural changes associated with releasing resentment or anger towards someone who caused harm, has found that forgiveness involves a specific shift in medial prefrontal cortex and anterior cingulate activity. This shift corresponds to a change in the narrative frame around the injury, from a frame centered on threat and wrong to one centered on understanding and release. What's notable is that the neural signature of forgiveness overlaps substantially with the neural changes associated with successful emotional memory integration. The same regions, the same direction of change. Sleep researchers have noted that the narrative reframing work of forgiveness appears to accelerate REM processing of the associated memories. The brain cannot easily process what has not, in some form, been released. The experience of dreaming about a former partner who is deceased, rather than merely absent, introduces a specific dimension to the emotional processing literature. Grief researchers have found that post-loss dreams of the deceased follow a characteristic trajectory from distressing, incomplete, or ambiguous encounters in early grief to more comforting, resolved, or ordinary encounters as grief progresses. What's notable is that this trajectory closely mirrors the clinical markers of healthy grief processing: initial pain and disorganization, followed by gradual integration and reorientation. Researchers have proposed that these grief dreams serve a specific function. They allow the internal model of the deceased person to continue updating even after the person is no longer physically present, to provide new information. The brain maintains the relationship until the model can be revised. The question of whether dreams can communicate something meaningful beyond the neurological processing function has been treated cautiously by sleep science, which has rightly resisted the more expansive interpretive claims of earlier psychological schools. But the phenomenological reports of dreamers are not entirely separate from the research. Studies in which participants describe their dreams and then assess their subsequent emotional state have found that certain dream experiences, those in which a difficult situation is navigated to resolution, or in which forgiveness is exchanged, or in which there is a sense of completion, are associated with measurably reduced emotional distress the following day. The content of the dream doesn't carry meaning the way a message does, but the quality of the processing, whether it moves toward resolution or remains in replay, appears to have real downstream effects. Research on what sleep scientists call mood regulation across the night has found that the emotional tone of REM dreams becomes more positive over successive sleep cycles in most people under normal conditions. The early night REM cycles tend to involve more emotionally neutral or moderately negative content. The late night cycles, during which REM becomes longer and more intense, tend in healthy sleepers to show a shift toward more positive emotional content, more affiliation, more resolution, more scenes of connection. Sleep researchers have proposed that this late-night emotional resolution shift is part of the mood-regulating function of sleep. The night is not just processing the difficult content. It is actively working to carry the sleeper toward morning in a more regulated state than the previous evening. Research comparing the emotional memory processing of individuals with different attachment styles has found meaningful differences in how the REM system handles relationship loss. Individuals classified as anxiously attached, those whose attachment system is characterized by heightened vigilance to signs of abandonment and rejection, show higher rates of intrusive emotional dreaming following loss, longer timelines to amygdala normalization, and more fragmented sleep architecture during recovery. Individuals classified as securely attached show faster reduction in emotional reactivity, less intrusive dreaming, and more coordinated REM processing. The attachment style formed early in life appears to influence not just the conscious experience of loss, but the efficiency of the neurological processing system that handles it during sleep. The science of expressive writing, pioneered by psychologist James Pennebaker, has demonstrated that writing about emotional experiences produces measurable health benefits, including improved immune function and better psychological outcomes following loss. The neurological mechanism appears to involve the same prefrontal amygdala regulatory pathway as verbal emotional disclosure. Writing about an emotional experience with narrative structure, not just listing feelings, but constructing a coherent account, reduces the amygdala's ongoing salience tagging of the associated memories. Preliminary research has examined whether expressive writing before bed accelerates the emotional memory processing that occurs during subsequent sleep. Early findings suggest it may participants who wrote for 15 minutes about a recent emotional experience before sleep showed reduced distress-related dream content over subsequent nights. 50 facts in. And the question that opened this hour: why can't we stop dreaming about someone we've already decided to move on from? Has shifted its frame. It began as a question about inability, about being stuck. It has become a question about process, about what the brain is doing that appears on the surface, like being unable to move on. What the second half follows is the place where those two frames most directly collide. The tension between the brain's need to keep processing and the mind's desire to be finished. Because here is what the research makes increasingly clear. The distress of the replaying isn't the processing. The distress of suppressing it, of being ashamed of it, of trying to stop it before it has run its course. That is where the process gets interrupted. The second arc begins there. What just came into focus? The tension between the brain that needs to keep processing and the part of you that wants to be done may not be abstract for you right now. You may be carrying a version of this. Something you are tired of still feeling. Something you have told yourself you should be past. Feel your chest for a moment. Not to change anything, just to notice. The fact that it is still there does not mean the processing has failed. It may mean the processing is still running. The second half follows what happens when you stop interrupting it. Now we continue. The suppression of emotional memories. The deliberate attempt to stop thinking about someone by redirecting attention away from associated thoughts has been extensively studied, and the findings are consistent. Thought suppression in the short term produces a brief reduction in conscious access to the suppressed content. In the medium term, it produces what researchers call the rebound effect. Suppressed thoughts return with greater frequency and intensity than before. This is sometimes called the white bear effect, after a demonstration by psychologist Daniel Wegner. The neural mechanism involves the prefrontal cortex working to inhibit the default mode network's spontaneous memory reactivations. When those cognitive resources are depleted, the suppressed content is released. The brain that is forced to suppress is the brain that rebounds. The rebound effect from thought suppression has a specific relationship to sleep. Research has found that individuals who actively suppress thoughts about an ex-partner during the day show increased intrusive dream content about that person during subsequent nights. The suppression works during waking hours, at the cost of significant cognitive effort, and then fails during sleep. When the prefrontal cortex's inhibitory control is reduced, the REM system processes what the waking mind was trying not to see. The emotional content that was blocked from daytime processing doesn't disappear. It accumulates in the processing queue and surfaces with greater intensity in the dreams that follow. Research on acceptance-based approaches to emotional regulation, drawing from frameworks like acceptance and commitment therapy, has found that accepting the presence of an emotional experience without attempting to change or eliminate it produces faster amygdala normalization than suppression strategies. From the brain's perspective, acceptance may work in part by removing the secondary layer of processing burden, the distress of being distressed, the rumination about the rumination, the shame about still feeling what you feel. When this secondary layer is removed, the primary emotional processing can proceed more efficiently. The research is careful about what this means. Acceptance does not mean passive resignation. It means reducing resistance to what is already happening, allowing the processing to run. The anterior cingulate cortex, a region involved in conflict detection, error signaling, and the experience of social pain, shows characteristic activity during both the experience of relationship loss and the period of recovery. Research has found that the anterior cingulate's response to social rejection activates overlapping neural circuits with its response to physical pain. This is not metaphor. The brain processes the end of a significant attachment through some of the same pathways it uses to process bodily injury. Over the course of emotional recovery, anterior cingulate activation in response to reminders of the lost relationship gradually decreases, measurably, over weeks and months of adequate sleep and processing. The social pain of loss follows a healing curve, not unlike the healing of a wound. Research on the dream lag effect. The tendency for emotionally significant experiences to appear in dreams, not the night immediately after the event, but 5 to 7 days later, provides insight into the architecture of emotional memory consolidation. The dream lag effect suggests that emotional memories undergo a preparatory phase in the days following an experience before they are ready for deeper REM integration. During this preparatory phase, the hippocampus is consolidating episodic details, while the amygdala continues to assess emotional significance. When the memory is sufficiently prepared, tagged, partially consolidated, and made available, it becomes accessible for the deeper REM processing that produces the dream. The mind prepares before it can fully process. The concept of emotional updating, the process by which the brain revises the emotional valence of a memory after additional information or time, is one of the central mechanisms of psychological recovery. Research has found that the process is gradual and iterative. Each exposure to a memory under conditions of low threat allows a small amount of updating to occur. Sleep provides those low-threat conditions. Specifically, the norepinephrine-depleted environment of REM, in which the most significant updating can happen, what researchers call extinction learning. The gradual reduction in fear or pain responses to previously threatening stimuli is largely a sleep-dependent process. The emotional meaning of a memory doesn't update all at once. It updates a little each night. In the quiet of a long REM cycle, the persistence of a person's presence in dreams long after a relationship has ended, sometimes years later, is not evidence of pathology or incompleteness. Longitudinal studies of emotional memory have found that even fully processed emotional memories can appear in dreams periodically, typically without the emotional intensity of the early recovery period. The dreaming brain's relationship with significant past experiences is not a linear journey toward erasure. It is a continued, low-level dialogue, an occasional revisitation that is more curious than painful, more familiar than distressing. The goal of emotional processing is not to make a person disappear from your inner world. It is to change the quality of their presence, from a source of pain to a part of the larger story. Research on the neuroscience of meaning-making following loss, the cognitive process by which people construct an understanding of what a loss means within the larger life narrative, has found specific neural correlates. Activity in the medial prefrontal cortex and posterior cingulate cortex, regions associated with self-referential thought and autobiographical memory, increases during periods of active meaning-making. This activity pattern is distinct from rumination. Even though both involve returning to thoughts about the loss, the distinction lies in directionality rumination circles, meaning-making moves. One searches for what caused the pain, the other searches for what it means and where it leads. The social dimension of emotional healing has neurological specificity. Research on oxytocin, a neuropeptide involved in social bonding, trust, and affiliative behavior, has found that its release during social connection can modulate the amygdala's response to social threat, reducing its activation and facilitating emotional processing that leads to recovery. Oxytocin is released during physical contact, but also during emotionally attuned conversation. In moments when someone listens with genuine attention and responds with genuine understanding, these social experiences of being seen do not simply feel better than isolation. They chemically modify the emotional processing conditions in the brain. Healing, the neuroscience increasingly suggests, is not only an internal process. It happens between people. Research on what is called narrative identity, the ongoing story people construct about who they are and where they have been, has found that the coherence of this narrative is a reliable predictor of emotional well-being. People who have been able to integrate difficult experiences into a coherent life narrative, not by minimizing the difficulty but by finding a place for it within the larger arc, show better psychological health across time. Sleep researchers have found that REM sleep activity during periods of emotional difficulty shows the highest correlation with narrative integration outcomes, the nights that produce more complex, resolved dream content appear to be building toward the kind of integration that shows up in recovered narrative identity. The dreaming brain is writing the story. The experience of anniversary reactions, the resurgence of grief or emotional pain around dates, seasons, or anniversaries associated with a loss, has a specific neurological basis. The brain encodes temporal context, along with emotional memories, the time of year, the quality of light, sensory cues associated with a particular season. When these contextual cues recur, the first autumn after a breakup, the first winter after a loss, they can trigger automatic reactivation of associated emotional memories. Even in people who have otherwise made substantial progress in recovery, anniversary reactions are not regressions. They are normal features of how temporally anchored emotional memory works. The brain is not forgetting what it has processed. It is responding to a cue that was encoded with the original experience. Research on self-compassion, the practice of treating oneself with the same kindness one would extend to a friend in difficulty, has found specific neurological effects on emotional recovery following loss. Individuals who score higher on measures of self-compassion show faster reductions in cortisol reactivity to loss-related stimuli, less amygdala hyperactivation in response to reminders of the lost relationship, and better sleep quality during recovery. Kristin Neff at the University of Texas, whose work has been foundational in this field, proposes that self-compassion reduces the secondary suffering layer, the self-criticism and shame that accompany primary pain, and thereby reduces the total emotional processing burden. Less secondary suffering means more efficient processing, both during the day and during sleep. The brain's capacity for emotional recovery is not fixed. Research in neuroplasticity has demonstrated that the neural pathways involved in emotion regulation, including the prefrontal amygdala connections that modulate emotional responses, are modifiable through experience and practice. Mindfulness-based interventions have been found to produce measurable increases in prefrontal cortex thickness and reduced amygdala reactivity over an 8-week period. These structural changes correspond to improved emotional regulation capacity and faster recovery from emotional disturbances. The brain you will use to process the losses of next year is not the same brain that processed the losses of 5 years ago. Its capacity changes. And the thing that most reliably builds that capacity, alongside whatever practices you cultivate during the day, is adequate, undisturbed sleep. Researcher Rosalind Cartwright, who spent decades studying the relationship between sleep and emotional recovery, conducted longitudinal studies following individuals through divorce. Her findings were specific individuals who dreamed about their former spouse during the divorce process, particularly those whose dreams showed emotional progression over time, from intensely negative to more neutral and eventually more positive content, showed better adjustment outcomes at follow-up than those who did not dream about their spouse or whose dreams showed no progression. Dreaming about the person wasn't the problem. The quality of the dreaming, whether it moved, whether it processed, predicted recovery better than whether the dreams occurred at all. More than halfway through the science of this question, and what has emerged turns the original frame almost entirely around. The brain that replays an ex-partner at 3 a.m. is not a brain that has failed to move on. It is a brain running an elaborate, biologically essential process of emotional model revision, using the neurochemically unique environment of REM sleep to do work that cannot be done the same way anywhere else. The replaying is not the obstacle to healing. It is, much of the time, the healing itself. What the remaining facts carry is the question of what this understanding makes available, not just intellectually, but practically, in the dark, where the work actually happens. Research on paradoxical intention, a therapeutic technique in which patients are instructed to intentionally try to produce the symptom they are trying to eliminate, has been applied to intrusive thoughts with meaningful results. When individuals who experience intrusive thoughts about a former partner are encouraged to allow those thoughts to occur, to observe them without judgment, and to recognize them as evidence of processing rather than failure, the frequency and distress associated with the thoughts typically decrease faster than in suppression conditions. The brain, when given permission to do what it is already doing, does it more efficiently. The same logic applies to dreams. Fighting what the dreaming mind is doing is not the same as healing. Allowing it is. The neural basis of continuing bonds. A concept from grief research describing the ongoing psychological relationship maintained with an absent person following loss, has been studied through neuroimaging. Individuals who maintain adaptive continuing bonds, a positive, non-distressing internal relationship with a lost person, show distinct neural patterns from those whose bonds remain distressing. Adaptive processing involves activity in the medial prefrontal cortex and default mode network regions associated with positive self-referential and other referential thought. Maladaptive processing shows heightened amygdala and anterior cingulate activity. The neural distinction is not between remembering and forgetting. It is between a memory held in fear and a memory held in peace. Research on sleep and identity reconstruction following loss has found that the periods of most active REM processing coincide with periods of most active psychological reorganization of self-concept. When a significant relationship ends, the self-concept, which was partly built around the relationship, requires revision. The brain needs to update not just memories of the other person, but its model of who I am in that person's absence. Studies have found that individuals in the middle stages of identity reconstruction show elevated default mode network activity during both waking, self-reflection, and REM sleep, suggesting that the same neural infrastructure is doing the identity work in both states. The dreaming mind is not just processing what was lost, it is building what comes next. The relationship between physical exercise and emotional memory processing offers another window into the sleep-healing connection. Research has found that acute aerobic exercise, a single session of sustained moderate-intensity activity, produces hippocampal neurogenesis in animal models and correlates with improved emotional memory consolidation in human studies. Post-exercise sleep shows enhanced slow-wave sleep and longer REM cycles. The combination of exercise-induced neurobiological changes and their amplification through subsequent sleep produces what researchers have described as a potentiated consolidation effect. Emotional memories processed on nights following exercise show faster reductions in effective charge. The body that moves during the day processes more efficiently in the night. Research on the phenomenology of emotional dreams, how dreamers experience and describe dreams about former partners, has found that a common feature of healing phase dreams is a shift in the role of the dreamer. In early grief dreams, the dreamer is often passive. Things happen to them. The lost person departs again. The dreamer is left waiting or abandoned. In mid to late recovery dreams, the dreamer increasingly becomes an active agent. They make choices. They speak. they navigate the encounter. Researchers have noted that this shift from passive recipient to active agent corresponds to a broader shift in psychological orientation to the loss, from a stance of being acted upon to a stance of agency and forward movement. The dreaming mind rehearses the recovery before the waking mind experiences it. The biology of attachment, the neurochemical system that binds us to specific people and creates the conditions for both love and loss, involves several overlapping systems. Oxytocin and vasopressin regulate bonding behavior and the formation of long-term pair attachment. The dopaminergic reward system creates motivation and desire around the attached person. The opioid system is involved in the feeling of comfort and safety in an attached partner's presence. When attachment ends, each of these systems undergoes recalibration. Research has found that this recalibration is significantly influenced by sleep quality. The opioid system's role in comfort and safety means that sleeping alone, particularly in the early period following separation, is not simply a psychological challenge. It is a neurochemical one. The social sleep hypothesis, a research framework connecting the evolution of REM sleep to the social complexity of human life, proposes that one function of REM sleep may be to process the complex, emotionally nuanced information that comes from living in a social world. Dreams, in this framework, are the output of a simulation system that models social relationships, their dynamics, their risks, their emotional textures, and updates the brain's social predictive models accordingly. Under this hypothesis, dreaming about a former partner is not merely emotional processing. It is social model revision. The brain is updating its predictions about a significant social reality that has changed. The complexity of human relationships is precisely what makes them require such extensive offline processing. Research on the long-term outcomes of emotional recovery following relationship loss has found something that challenges the narrative of linear healing. Recovery is not a straight line from pain to resolution. It is characterized by oscillation, periods of forward movement followed by periods of re-engagement with grief, often triggered by cues or anniversaries. This oscillatory pattern is not a failure of the process. Research by Margaret Struber and Henk Schut, who developed the dual process model of coping with bereavement, describes this oscillation as functional, alternating between confronting the loss and taking restorative breaks from it, is associated with better long-term outcomes than continuously engaging with grief. The brain knows to do this. It rests, returns, processes, rests again. The science of emotional resolution, the subjective experience of having processed a loss fully enough that it no longer generates the same distress, cannot yet be fully mapped onto a specific neural signature. What researchers can measure is the trajectory amygdala normalization over time, reduction in default mode, network activation in response to reminders, improved sleep continuity, reduction in the frequency of intrusive thoughts. What they cannot fully measure is the subjective experience of arrival, the morning when you wake, and the first thought isn't about them. The day you hear a song that was once unbearable and feel something softer than pain. What the science can say is that this arrival is not random. It is built, incrementally, from the inside, through exactly the kind of work that has been running through every night described in these facts. The big idea that has been slowly assembling across these 75 facts can now be stated directly. The brain that replays someone at 3 a.m. is not broken, not weak. not stuck. It is running an ancient, sophisticated offline processing system on exactly the work it needs to do. Dreams are not evidence of failure to move on. They are the mechanism of moving on. Each night of undisturbed sleep is a small, measurable reduction in the emotional charge of what is being carried. The remaining facts carry a different quality. The science has done its work. What comes now is what the science was always pointing toward, not the mechanism, but what the mechanism makes possible. Breathe slowly. The emotional memory system in your brain has been processing things since before you knew there was anything to process. Every night, regardless of what the day brought, regardless of what you told yourself before you closed your eyes, something in you was working. There's nothing left to do tonight except let it continue. Let your body settle into the weight it already knows. We're almost there now. The brain at the end of a long REM cycle in the quiet hours is not the same brain that began the night. Something has shifted. Small, measurable, real. The emotional charge on what was carried is a little lighter, not resolved, not erased, but lighter, in a way that compounds quietly across many nights. Healing does not announce itself. It happens in small, unremarkable increments, in the space between sleep cycles, in the quiet biochemistry of a norepinephrine floor that was reached sometime in the second hour of REM. You may not feel it happening. The system does not require you to. The replay that feels like being stuck is often the sound of a system that hasn't been allowed to finish. Not because the brain failed, because the conditions kept changing. Too little sleep, too much suppression, the noise of a daytime mind that couldn't settle long enough to let the work run. The amygdala doesn't have a shortcut. It cannot be talked into adjusting its salience ratings. It cannot be convinced to update its model of a lost person through willpower alone. It updates through the slow, chemical, nocturnal process of REM sleep running its passes. Night after night, a little at a time. Every significant loss changes the brain, not as metaphor, literally. The neural pathways that were built around the presence of a person continue to exist after the person is gone. The brain doesn't tear those pathways out. It builds new ones alongside them. Gradually. The old roads don't disappear. They just get used less. And the new ones grow more familiar with time. Research has found that people who sleep well through the period of grief don't grieve less. They process what they grieve more efficiently. The depth of the loss is not reduced by sleep. What sleep builds is the capacity to carry what cannot yet be set down, and to continue, even while carrying it. The brain's default mode network, the network of self-reflection, of autobiographical memory, of imagining others, is most active during sleep and during the quiet that precedes sleep. It is not a network of distraction or escape. It is the network of the inner life. What runs through your mind in the dark is not noise. It is the default mode doing its work. Research has found associations between consistent, high-quality sleep across adulthood and structural properties in emotion regulation regions of the cortex. These associations are still being mapped. Causal direction is not fully established, but the pattern suggests that the brain's capacity to hold difficulty with equanimity may be shaped, in part, by a lifetime of adequate sleep. The brain allowed to rest, repeatedly, across years, appears to develop greater resilience. The person you were before the loss and the person you are becoming are not the same person. The difference between them is built, in part, in the quiet architecture of your sleeping brain, in the narratives constructed during REM, in the model revisions running below consciousness, in the very small reductions of charge that occur each night. Research on post-loss growth, the psychological development that can follow significant losses, consistently identifies one factor above others as distinguishing those who grow from those who remain stuck: the willingness to allow the process to unfold without forcing an outcome. The brain can't be rushed. The amygdala has its own timeline. The REM system processes when the conditions allow. What the research asks is not effort. It asks permission. The 3 a.m. waking, the sharp surfacing from a deep dream, is not a failure of sleep. It is often a moment at the end of a long REM cycle in which the dreaming brain has done something significant. The distress of the waking is not the story. The processing that preceded the waking, quiet, unremarkable, necessary, is the story. There is a quality the science cannot fully name, something in the way emotional memory changes over time that is not only a reduction of charge but a transformation of meaning. The memory of someone you loved becoming something you can hold without being undone by. The science can measure the amygdala's trajectory. The experience of arriving at that place is yours alone. The sleeping brain works through the night towards something. Not perfectly, not in a straight line, but with a direction. The emotional content that enters the first REM cycle is not the same content that reaches morning. Something in the processing, however small, has moved and keeps moving, one night at a time. What the research on REM sleep and emotional healing makes clear is that the body already knows what to do. The system was in place before you knew you would need it. Long before this particular loss, long before you knew what losing someone felt like, the brain prepared for grief as part of its basic architecture. You arrived equipped. Sleep researchers have found that the emotional tone of the final REM cycle of the night, the long cycle in the hours just before waking, tends to shift toward positive affect in individuals who are moving through recovery. The night ends with something softer than it began. The brain, given adequate time and conditions, works in this direction, not because it is optimistic, because integration moves toward coherence. The science of attachment has found that secure attachment, the capacity to feel safe in relationship without being overwhelmed by the fear of its loss, is not only the product of early experience, it is something the brain can develop over time, through repeated experiences of being known and held, and through the slow work of processing what has been lost. The brain that processes loss builds capacity for love. Each grief, adequately processed, expands what the heart can hold. The dreams that come in the later months are different from the ones at the beginning. Not always happier. Sometimes simply quieter, less urgent, less fraught with the electrical quality of unfinished business. The dreaming brain, having done its work, visits these territories differently, with something that begins, slowly, over many nights, to resemble peace. Healing is not the absence of memory. It is the change in what memory does when it arrives. The memory that once stopped the breath, that arrived with its hands around your throat, loosens over time into something that can be held at a distance, then held closer, then held without the breath stopping at all. The memory remains. Its power changes. The brain does not grieve alone. It has helped the body that carries it, the REM cycles that process it, the people who witness the process and hold it in their attention. Healing is not a private neurological event. It is a biological and social event, running simultaneously on multiple channels, all of them pointing in the same direction. The science of sleep and emotional healing does not promise that this will stop hurting. It promises something more precise, that the brain, given what it needs, will continue its work. That each night, something small changes. That the process is real, and it is moving, even on the nights when it doesn't feel like it is. The quieter hours, the late ones, the ones in which this fact is speaking, are when the most significant REM processing typically occurs. If you are still here, still listening, the work is still running. Somewhere in the cycles to come, the material that was carried into this night will be a little lighter by morning. Research has found that the quality of the first thought upon waking, whether it arrives with heaviness or with something more open, shifts over the course of a recovery period. Not immediately, not in a predictable sequence, but over time, gradually. The morning begins differently. The brain delivers something other than what it delivered the morning before. Sleep made that possible. The person who is replaying in your dreams is not there to torment you. The brain is not being cruel. It is doing, as patiently and as efficiently as conditions allow. The only thing it knows how to do with what matters most, it is processing. Slowly, in the dark, with great care, returning a little closer to rest each night. The science of emotional closure is not the science of ending. It is the science of changing what a memory is. The attachment that was formed, the neural pathways built around a person's presence in your life, does not have to be destroyed for you to be free. It has to be transformed from something that holds pain into something that holds the truth of what was there. And this, finally, is the answer to the question, why can't we stop dreaming about someone we've already decided to move on from? Because the decision to move on is made by the prefrontal cortex, and the healing is made by something older, slower, and more patient. A system that runs below decision, below willpower, below the part of you that is tired of still feeling this. That system is not asking for your permission. It only asks not to be interrupted. The answer is not that you can't move on. The answer is that you are already moving. You have been moving every night. The dreaming is the road. Something changed in the space between the first fact and the last. Not because the loss became smaller, but because what the loss was doing became clearer. The amygdala was not punishing you. The hippocampus was not being sentimental. The dreaming brain was running a process as precise and as purposeful as anything the body does to heal a wound. Incrementally, in the dark, below the level of any decision you could make about it. What looked like being unable to move on was almost entirely the moving itself. The replaying was the repair. The brain that couldn't stop was the brain that wouldn't stop working on your behalf, in the quiet, with exactly the material it was given. The Sleepy Mind Science Healing to Fall Asleep playlist has been following this thread. The biology of what the mind does with what it cannot simply set down. The next video moves further into that territory. What happens when what the brain is processing has been carried not for months, but for years? That video is waiting whenever you are ready. The processing that ran through tonight doesn't stop when the voice does. Let your body settle into what it already knows how to do. If sleep comes, It carries you into the part of the work that only runs when you stop watching it. But if your eyes are closed, stay there. Rest well, weary one. The replaying was never what it looked like. It was always underneath. The sound of something healing, where science becomes the softest place to rest.